Welcome back to part 3 of the series on making a Tic Tac Toe website. So today, we're going to implement the functionality that lets you play single player or with a computer instead of playing by yourself or a friend. And the way we are going to do that is using an algorithm called Minimax. So the first part of the video will be describing how it works, and the second part is implementing it. So let's just get started. So of course, here you have the board. And how do we represent the moves you can make? So the way we can do it is basically draw a couple branches, each for an individual move. And you can say, for example, this one will be when you have put the O here, and this would be when you have put the O in this position. And now the game is finished. But let's say if you have more, you can just continue branching it off until you reach the end or a certain depth that you decide you should stop at. And of course, drawing boards on every single one would be tedious. So the way we're going to represent it from now on is basically as a circle, kind of like different stuff like this, right? Each leading to it like a separate outcome. And this is what we're going to call a tree. So to explain this, I'm actually going to use chess as an example. And you might be wondering why I'm using a more complicated game to explain a simpler one. And basically my point is to get you to see that the exact mechanics of the game doesn't matter. The basic logic stays the same. So let's say we have a chess board at the state of whatever it is. And now let's say you can only move 2 different moves to keep it simple. So maybe you can move the pawn in one and you can move a knight in the other. And now we're just going to draw this. So to decide which one to move to, all we need to do is find a way to assign a score. This score doesn't have to be like a precise number that means anything. It just has to be the bigger the score is, the better. That's all you need to have. So let's say this somehow is a score of 10. And let's say this is -3. And the way we could determine the score changes based on the game, of course. But for chess, it might be just like whether you have like taken a new piece, or maybe whether you got a checkmate, or just like maybe you got into a more strategic position. You can change the score based on anything you want. But let's say we have that. And now, of course, you just need to compare which one is better and pick the better one. So this, we can just put the number 10 here. We pick the better one. Or actually for the top case, you can just choose to go to 10. And that's basically it. But if you're an actual computer just following this, you will lose pretty quickly. Because while this may seem like a temporary victory for you, your move might have let the opponent give you a checkmate, or maybe have led the opponent to take your queen or something like that. So what you have to do is basically look more ahead into the future. So let's say we look ahead more. So we erase these numbers, we don't evaluate them here, but we just continue growing on the tree. Maybe it's here you have 3 possible moves for them, and also here maybe you just have 2. So these, of course, are not your decision. This is the other player's turn to move. So let's just assign values to this again. Maybe this is a -5, this is a 3, this is a 0. And this might be like, let's say a 10, this could be a 2. So this means that if you are the other opponent, of course, they do not want you to win. They want to win. So they will effectively choose the smallest option. So they will choose -5, which is the worst option for you and the best option for them. And now, of course, this side, they will also choose the worst option. So that would be a 2. And now you have to decide between which one do you possibly want to pick. So you have to pick this side, because this side, it will give you and guarantee you a 2, while the other side, it will give you a -5 because they will choose the worst option. If you find 2 layers is not enough, you can just keep growing the tree. So let's say instead of 2 layers, we go for maybe 3, and this is the result. So now, of course, it's back to your decision. So now let's just erase all of the numbers here, and we find new scores for each of these. So let's say here is a 10, and here's a 2. We won't be drawing every single one just to save a bit of time. You had the option to choose a 10. And maybe here is a -5, you have no choice but choose a -5. And here, of course, it is their decision again, so they will choose the worst number. And so basically this entire branch will give you a score of 5, -5. And here, same thing. So that is basically how you continue. You switch between the person who picks the lowest score, which is your opponent, and yourself, which you will of course pick the best score for yourself. And you can just alternate back and forth choosing the biggest number and the smallest number. And that is why this algorithm is called Minimax. With a game of chess, there are so many different ways you could make a move. So for each of these layers, it's not 2 moves, there's probably hundreds just for one layer. And that of course grows exponentially because there's hundreds for each of these layers and hundreds for each of those. So of course it becomes very computationally expensive later on. So the way you solve for that is just limit the amount of layers you're going to look to, like limit the amount of steps you're going to look forwards to. So maybe that would be 5, maybe that would be 3, who knows. But for a game like Tic Tac Toe, there are a very small possible amount of ways that you can play it. So we can literally draw the tree all the way 9 steps deep until you reach its conclusion, which would be either a draw, a win, or a lose. So instead of writing a complicated scoring function that tells you, for example, whether this is better than this, you just have to know that whether you have won, lost, or it's a draw, and that's it. So the scores will be very simple. If you are a draw, that would be a 0. If you won, that will be a 1. If you lost, that would be a -1. And of course, the positive and negative could be anything they want. It could be 500 and -500, 500 and -25. All you need to do is that the higher number is the best one. So now on to the code. In the previous video, I quickly realized you cannot go over every single aspect of web development and making a website in one video. It has been over 35 minutes and I still missed some little parts. So I have actually edited some parts off of like without being in a video, and they're basically really small parts. I have documented them pretty well in the comments. So essentially most of them are just small CSS tweaks, for example changing the font of the button and changing the padding a little bit. And also I have a little bit of code for some previous things that didn't really change that much. If you are interested, you can go back to the comments on GitHub, which I link below, and edit them accordingly. So now let's actually get on with our code. Now let's just quickly get the player select out of the way. So the thing we're gonna do first is go to the script and add defer here, and all that does is basically makes it so that the script runs after the page is loaded, so you can just call document.getElement by ID, etc. directly from the script itself without wrapping it in a window on load. So let's say we declare a variable called is2player equals to true at first, and or we can actually change it to false. So we have single player as a default option, and to make that default, I guess we can just make it so that we rearrange first player to be the first style. Great. And then we can just go here and say let player select equals to document dot query selector, and then we select the ID player select, which we indeed have assigned here. And then what we can do is just say dot player select dot add event listener change equals to this, and we can make an arrow function, and we can just say log or console.log player select dot value, like that. Great. Opening up the console, we can in fact see that when you change the player select, it changes between the value of 1 and 2, and it logs it here. So we just have to say if player select value equals to 2, we can just say is 2player equals to true, else is 2player equals to false. And we're done with the player select. So we're gonna write another function called make player move, and this essentially is a wrapper around the make move function that like checks if the player is allowed to click on a square. So we can just say if step modulo 2 is equal to 0, which means that, you know, if the step is a X turn, which is a player's turn, or if it is 2player, which means that if it is 2player, of course you can just move ever whenever you want. If it is, then we call make move X and Y, and we just pass in those variables in. If it's not, it just like does nothing and returns. And then we can just go back to the HTML and change all of these from make move to make player move, and like that we're done. So let's write the minimax function. So we can just say function minimax like that, and then we're going to pass it in board and step. So usually for most Minimax applications other than Tic Tac Toe, you could also have something that says is max player or something like that, which shows that basically which side you're on, whether you're trying to get the highest number or the lowest number. But we don't need that because we can figure it out by just the step of the game. So the step will just be like the actual step in the game. So nothing is the step 0, and all of them filled would be step 8. And so now we have the function. And this will be done with recursion, and I'll elaborate more on how that works later. But with all recursive functions, of course, the best thing you should do is to think about it from like the bottom up. So like the final layer, like when it stops, up until the first time it's called. And that way you can kind of declare like when you should return instead of recursing more. So let's just write score, let score equals to get winner, and then we pass it the board. And this get winner function is one that we haven't wrote, so let's just write that now. And get winner, it will accept board as an argument, and then we can say let win equals to check win, and then we can pass it in board. So check win is a function that I wrote in the previous video, which basically just checks for all of the lines manually and checks like if all 3 of them are the same, which means that it's in a line, and so we return that line. So to make this work, we actually have to make it so that you had to pass in a board. Previously, it was just using the board declared in the global variable space. So that means we have to also update this part in the check wins, so the previous part also works. But now once we have that, everything is good. So here, we can just say if win, we can just say let point equals to win 0. So we're essentially just copying the previous part where we wrote the check win function manually but without making it a function. So we can just go here and say let is x equals to that point. So basically we get that point on the board, and if it is a square, of course it would be x. If it's not, it would be a circle. So we can just say return is x, and if it is, just return 1, else -1, like that. So we can say here if there is a score, so if it has 1, we just immediately return, and this is a special syntax. If you write your if statement on one line, you actually don't need the brackets. And now here we're going to return an object actually, so we can say score, or to simplify, we can just write the score name itself, like that. So we return score if it has 1. Another way it has 1 is if the step equals to 9, and then we return score 0. So that means it is a draw if it actually reached, the completion without actually winning. So now we have all the things to check for the score and whether the game has ended. Okay, now let's write a for loop. So we're going to loop through all of the items in the grid by saying for let I in board and for let j in board I, and this basically just gives you all of the indexes. So it loops through the x's and y indexes like that. And then what we can say is to check if it is empty, so that if that square is empty, you make a move. So you can say if board I j is equals to square empty, and this is a quirk with the way that I made the array so that there's 2 empty states for the placeholders, but that isn't like really important to the minimax function itself. But basically we just check if it's empty. So we can say if it's square empty or circle empty, which both means it's empty and you can move. Great. And if it is, what you can do is basically change the board and makes a move. And when we change the board like here, if we just change it like board ij equals to something, this will actually modify the board basically everywhere because it's referenced and not copied. So let's just make a function called copy board, which basically does what you want and just copies the board. So let's say copy board like that, and this is a really simple function. You can just return board.map row equals to row.slice. So dot slice, if you pass it in nothing, it basically creates a copy. So for each of the 3 rows it creates, you kind of slice it like that. So we can just say let copied board equals to copy board, and then we can just say copy board, copied board ij, and we can make the move actually and like modify the array by saying equals to step, so modulo 2, so go to 0. So if it is even, then that means it would be square filled, also circle filled, like that. And then we can actually call the minimax function again. So we can say let result equals to minimax, and here's where the recursion happens. So minimax, we're going to say copied board, pass in that, and then what we're going to do is step plus 1, because here the step increased because you have moved that step, and so we can just pass that in like that. So now we do the minimax part of minimax. So we can declare a variable outside the loop, say, let's say let best score, and this basically keeps track of the best score you have possible. When it is unset, although it is a best score, we're not going to give it like the best score ever. We're going to give it the worst score possible and increase that score whenever we come across a better score, right? So we can just say step modulo 2 equals 0, and if it is even, that means you want a higher score because you're on, the player side kind of. So you want a higher score, which means you would give it a value of negative infinity for the lowest score possible, and then you give it a positive infinity for the highest score possible when you want a negative score, so that now whenever you get any number, it will be the best number, kind of the best score. So here we can just say in the loop again, let score equals to result dot score, like that. So we can say if step modulo 2 is equal to 0. So if you're on the player side, what you can do is check if the current score is greater than the best score, and if it is, we can do 2 things. So we just set the best score equal to the score, and so we're actually gonna do a little part of something that isn't isn't in normal minimax functions, but we can actually just keep track of the best move also here. So we can just give it an np object for here, and basically the best move will be equals to x I j y j. So that kind of like creates the best move and sets it, and saves it and returns it. And then we can just say like else if it is not our move, basically copy the same thing, and the only change would be to if the score is less than the best score, which means that you try to get the smallest number if you are the opponent. And that basically is it for the minimax function. All we need to do is basically return the results in the bottom. So we can just say return score best score move best move, and we're done with the function itself. Now that we have written the minimax function, all we need to do is call it, and we're going to call it actually in the make move function, so that every time the player makes a move, the move is automatically called. So we're going to put it after this if conditional, so if it has 1, so if it's not 1, and also if it's not a draw, just like if it's a normal move, then what we can do is basically call the minimax function. And we also have to have another if, so that checks if it is not 2-player, so that when it's 2-player, it just like shuts off permanently, and it is the correct move. So step modulo 2 is equal to 1, which is a computer's move. So if it is, then we actually do the calling of the computer. So in here, we can actually add a timeout, because the computer calculates everything kind of instantly. We can really make a timeout a delay, so it looks like the computer is thinking, and also gives the user a little bit of time to see the changes basically. So we can set timeout, make an arrow function, and in here we're going to write the code, and we can give it half a second of set timeout. So here we can say let's just console.log the minimax function to see what it gives you. So we can say board and step, we just pass in those things. And now let's just reload, let's click, and you can see it tells you the score is 0, and the reason is it will always be 0 because technically, if you play perfectly, you will always have a draw game. Basically, the computer wins by relying on you making a mistake. And that's the only way the computer can win. But it tells you that the move it wants to make is at x0, y0, so it tells you that they want to make a move here. So with that information, we can actually make the move. So we can say let move equals to minimax.move. And then we can just call make move, move.x, move.y, like that. And we're done. And you can see it plays for you and it automatically wins. So let's try something like this. The circle goes here, and let's say we do something like this. You can see it blocks your move. And if you try to block that, it does that, etc., etc., until you reach the end. So now basically everything is done. So here's where I would usually say, thank you for watching, etc., etc. But there's actually a couple fun things that you could do. So first is that what if we try to make it so that computer plays itself? And all we need to do for that is basically make it so that the computer doesn't only play on its own move, so it will play every single time. So all we need to do is get it started by picking a piece, and you can see it plays itself all the way after. And this kind of makes it so that it always draws, because if we play perfectly, it will always be a draw. But still, it is pretty fun to watch, and you can see it animating. Great. And there's another thing that you could do that's pretty fun, and that is, instead of picking the best possible solution, pick the worst one, so that the computer always makes it so that you cannot lose. So let's just go to the minimax function again. Instead of returning score, we return the score -1 or times -1. So we kind of flip the score so that it thinks the best solution is the worst solution, etc., etc. So that now when you play, you can see it doesn't pick the correct one, and because that will cause it to win, it manually picks the one that makes it so that it can't win. So that's the solution, and you can see no matter how hard you try to lose, you can't, and you can very easily win. So now you can see it always makes it so you cannot lose, and that is always pretty fun to play around with. There's a couple more things that I will leave as an exercise to you, and that is, first of all, so this is completely deterministic. So when you press the center one, it will always pick the top right corner. You can play the exact same game multiple times. And the reason for that is that it always picks the first one with the current best score. One thing that you could do is that instead of just making it the first move, like that is the best score, because there are so many different choices that could lead to the same outcome, you can make it so that whenever you encounter a move with the same score, you will kind of push it to an array, and it randomly chooses a choice out of those arrays that have the same value. And that could make it so that it's a bit more fun to play over and over. But I think that is basically it. So if you enjoyed the video, thank you for watching, and please like and subscribe. It supports my channel a lot, and I will see you next time.